Hi dear students, welcome to JZ classes. This is the NEET PYQ series of JZ classes. In today's video, we are going to discuss some questions of dimensional analysis. This is the part 2 of dimensional analysis. If you haven't watched the first part, please go to the link in the description. So let us go to the questions. So the first question is the dimensions of mu 0 epsilon 0 the whole power minus 1 by 2 r. This is a question that is asked in 2012 and 2011. How can we do this? We can do this either by finding the dimensions of mu 0 and epsilon 0, then substituting and then finding the square root, right? But there is another easier method. If we know an equation that involves these two terms, we can find the dimension of this quantity. Okay, as you know, the velocity of an electromagnetic wave is given by c is equal to 1 by root of mu 0 epsilon 0. This is the velocity of light. So this quantity has the dimension of velocity. So mu 0 epsilon 0 the whole power minus 1 by 2 is having the dimension of velocity, that is lt raised to minus 1. I hope you have understood it. So the option is option C. So let us move to the next question. Question number 2. The dimension of 1 by 2 into epsilon 0 e square, where epsilon 0 is the permittivity of free space and E is the electric field is. So you have to find out the dimension of this quantity, that is 1 by 2 into epsilon 0 e square. So 4 options are given. So this is a simple question, right? So try to do it yourself. After that, we will check the options. Have you got the answer? If not, let's check. So the quantity 1 by 2 epsilon 0 into E square. So this quantity is actually the energy density due to an electric field. So this is the energy density. 1 by 2 into epsilon 0 E square is the energy density. So we know that the mass density rho is equal to mass divided by volume. Similarly, the energy density is equal to energy divided by volume. So mass density is equal to mass by volume. Likewise, energy density is equal to energy by volume. Now, I will tell you a trick to find the dimension of energy. Maybe most of you know it, but for those who don't know, here it is. The dimension of energy is equal to the dimension of work. So the dimension of energy is equal to the dimension of work. So this is an important point. Always keep this in mind. This will help you to solve many problems. So the dimension of energy is equal to the dimension of work. So what is the dimension of work? So work is equal to force into displacement. So what is the dimension of force? Force is mass into acceleration times the dimension of length. Therefore, it becomes ml square t raised to minus 2. So this is the dimension of work. So the dimension of work is ml square t raised to minus 2. Therefore, the dimension of energy is also equal to ml square t raised to minus 2. Therefore, we can write it here, that is ml square t raised to minus 2. And the dimension of volume is L cube. Therefore, we can L cube. This L square and L cancels and we get it as m L raised to minus 1 t raised to minus 2. So this is the answer. So the dimension of 1 by 2 epsilon 0 into E square is equal to m L raised to minus 1 T raised to minus 2. So I hope you have got this answer. If not, check whether where you have it got it wrong. Okay. The correct option is B, option B. If instead of 1 by 2 into epsilon 0 E square, if they are asked to find B square by 2 mu 0's dimension, we can also follow the same procedure, because B square by 2 mu 0 is the energy density due to a magnetic field. Therefore, we will get the same dimension as that of 1 by 2 into epsilon 0 E square. So the dimension of 1 by 2 into epsilon 0 E square is equal to the dimension of B square by 2 mu 0. Okay, take it down. Question number 3. Which one of the following groups have quantities that do not have the same dimensions? We have to find out quantities that do not have the same dimensions. So let's check. The first one is pressure and stress. We know that both are having dimension of force by area. So this one is having same dimensions. Next is velocity and speed. You know that one is a scalar quantity and this is a vector quantity, but these two are having the same dimensions, that is having the dimension of velocity. So these have same dimensions. What we know that work and energy have same dimensions. So the answer must be force and impulse. Let's check. We know that the force is having the dimension of mass times acceleration, that is ml t raised to minus 2. And impulse is force into dimension of time. Therefore impulse is equal to ml t raised to minus 2 into dimension of time. Therefore it will be equal to t raised to minus 1. So dimension of force and impulse are not equal. So option C is the correct answer. Question number 4. Which two of the following 5 physical parameters have the same dimensions? So 5 physical parameters are given: energy density, refractive index, dielectric constant, Young's modulus, and magnetic field. So which two of the following 5 physical parameters have the same dimensions? So you have to find a group of 2. So the options are B and D, C and E, A and D, and A and E. So let's give it a try and we will solve it. Let's analyze each of these 5 parameters and find which of the two is having same dimensions. The first is energy density. So energy density is energy by volume, and the dimension of energy is same that as of work, and the dimension of work is force into displacement, and the dimension of volume is L cube, L square, and L cancels, and we will get m L raised to minus 1 T raised to minus 2. So this is the dimension of energy density. So this is the dimension of energy density. The second one is refractive index. You know that the refractive index is a constant and it is equal to the velocity of light in vacuum divided by the velocity of light in a medium. So both of these is velocity, so refractive index is not having any dimension. The next is dielectric constant. The dielectric constant is also known as relative permittivity constant. It is denoted with letter K and it is equal to epsilon m divided by epsilon 0. So this epsilon m is the permittivity of the medium divided by permittivity of free space. Since like refractive index, both the quantities in the numerator and denominator are of the same type, so this constant is also a dimensionless quantity. The next is Young's modulus. Coming to the modulus of elasticity, we have Young's modulus, bulk modulus, shear or rigidity modulus. So whatever be the modulus of elasticity, it will be having the dimension of stress by strain. Okay, and the strain is a quantity which gives the change in dimension by original dimension. So the strain is also a dimensionless quantity. Why? Because it is the strain is equal to change in dimension by original dimension of the length. If it is change in length by original length, or it will be change in volume by original volume, so the strain is not having any dimension. Next is stress. Stress is having the dimension of force by area. That is force, that is mass into mass times acceleration divided by L square. This L and L square cancels, and we will get m L raised to minus 1 T raised to minus 2. So this is the Young's modulus. Next we have to find the dimension of magnetic field. For finding the dimension of magnetic field, I'm going to use an equation, that is F is equal to IBL. So this equation is the force acting on a current carrying conductor placed in a magnetic field. You studied it in plus 2, or those who are in the 11th class will study it in 12th. So the dimension of magnetic field is equal to the dimension of force divided by dimension of current into dimension of length. Okay, so the the dimension of force is mass times acceleration. Okay, the dimension of current is denoted with I. Sometimes it is denoted with I, or it is denoted with A. And the dimension of length here, this L and L get cancelled, and we will get the dimension of magnetic field B as m L raised to 0 T raised to minus 2. This A goes upward and it becomes A raised to minus 1. So this is the dimension of magnetic field. So this refractive index and dielectric constant are dimensionless quantities, and magnetic field is having dimension. These two are not equal. Okay, this A and D are equal. This A and D will be the answer. I think you have understood this. Okay, please take it down. So the correct option is option C, that is A and D. We learned how to find the dimension of magnetic field using this equation, that is F divided by current into length of the conductor. So how to find the dimension of electric field, that is E. We know that the electric field is equal to F by Q, that is, this is the force and this is the charge. Therefore the dimension of electric field is equal to the dimension of force divided by dimension of charge, and the dimension of force is mass times acceleration, and the dimension of charge is current into time. You know that current is equal to charge divided by time. Therefore charge is equal to current into time, and current is denoted with the letter A for expressing its dimension. Time is denoted with T. Therefore the dimension of electric field E is equal to m L, this is T raised to 1 T raised to minus 3, T raised to minus 3 A raised to minus 1. So this is the dimension of electric field. So take it down. So let's move to the next question. That is question number 5. The dimension of Planck's constant are same as time, frequency, angular momentum, and velocity. Okay, we know that the energy is equal to h into nu. There is the energy, h is the Planck's constant, and nu is the frequency. Therefore, dimension of Planck's constant is equal to dimension of energy divided by dimension of frequency. And we know that the dimension of energy is same as that of the dimension of work. Therefore, it will be equal to force into displacement, and therefore ml t raised to minus 2 is mass into acceleration is force into displacement. Therefore, L becomes L square divided by frequency. Frequency is inverse of time. Therefore, it will be having the dimension t raised to minus 1. Therefore, the dimension of h at the Planck's constant is equal to m L square, this t raised to minus 1 and 1 t raised to minus 1 cancels here, and we will be having t raised to minus 1 here. Therefore, ml square t raised to minus 1. This will be the dimension of Planck's constant. So let's check the options. First one is time, it's incorrect. Frequency, this is also not correct. Velocity, no, velocity is L t raised to minus 1. So angular momentum will be the answer. But we have to check. Angular momentum L is equal to m in v into r. This is mass, this is velocity, and r is the distance. Therefore, the dimension of angular momentum is equal to mass, velocity is L t raised to minus 1, then again distance r, it is ml square t raised to minus 1. ml square t raised to minus 1. This is the dimension of angular momentum. So both are equal. Let's move to the next question. Question number 6. The ratio of dimension of Planck's constant and that of moment of inertia is the dimension of. So we have to find the ratio of dimensions of Planck's constant and that of moment of inertia. So we have Planck's constant h here, and we have the moment of inertia. So we have to find the ratio of these two dimensions. But we don't know any direct relationship between Planck's constant and moment of inertia now. But we know that the angular momentum, I denote angular momentum with L cross to avoid the confusion with the dimension of length, is equal to I omega, where L cross is the angular momentum, I is the moment of inertia, and omega is the frequency. And we know that L by I will be equal to omega. Okay. And in the previous question, we find that angular momentum L cross and Planck's constant h both are having equal dimensions. Therefore, we can, instead of L cross, we can substitute this h. Therefore, the dimension of h divided by dimension of moment of inertia is equal to dimensions of angular frequency. So now, what is the dimension of angular frequency? Angular frequency omega is equal to theta by t. The theta is in radians. It does not have any dimensions, but it has a unit. Therefore, omega is equal to 1 by t. Therefore, the dimension of omega is equal to t inverse. So, therefore, dimension of omega is t inverse. So, let's check the options. Time, that's incorrect. Frequency, that is, this is equal to the dimension of frequency. So, option B is the correct answer. Actually, the previous question and this question is related based on that, the knowledge of the previous question, they are asking this type of question. So take it down. Before going to the next question, I will tell you how to derive the dimensions of these quantities, that is voltage, resistance, inductance, and capacitance. So let's first take voltage. We know that the voltage, for voltage we can write power is equal to voltage into current. Therefore, the dimension of voltage is equal to the dimension of power divided by dimension of current. And we know that power, dimension of power is power is energy divided by time. Therefore, the dimension of power can be written as dimension of energy divided by dimension of time into dimension of current. Therefore, the dimension of voltage is equal to the dimension of energy is the dimension of work, that is m L square t raised to minus 2 divided by the dimension of time, that is t, dimension of current, that is A. And solving this becomes t raised to minus 3. Therefore, m L square, this t goes upward and becomes t raised to minus 3 A raised to minus 1. So this is the dimension of voltage. So have you understood this? Is it easy, right? So please take it down. The next one is resistance. We know that the power and resistance is related as P is equal to I square R. Therefore, the dimension of resistance is equal to the dimension of power divided by dimension of current, the whole square. Now, we know that power is equal to energy by time, and therefore the dimension of resistance becomes the dimension of energy divided by dimension of time into dimension of current, the whole square. Therefore, the dimension of resistance is equal to the dimension of energy is the dimension of work, it is ml square t raised to minus 2 divided by dimension of time, that is t itself. Dimension of current is a square. Therefore, the dimension of resistance becomes m. Then we have L square. Then we have t raised to minus 3 a raised to minus 2. So this is the dimension of resistance. M L square t raised to minus 3 a raised to minus 2. Next we have inductance. For inductance, I'm going to use the equation of the energy stored in an inductor. That is, the energy stored in an inductor E is equal to half L into I square, where E is the energy stored, L is the inductance, and I is the current. Therefore, the dimension of inductance is equal to the dimension of inductance. The dimension of inductance is equal to the dimension of energy divided by dimension of current, the whole square. Therefore, the dimension of energy is the dimension of work, that is ml square t raised to minus 2. Then we have the dimension of current, that is equal to a square. Therefore, the dimension of inductance is equal to m. Then we have L square. Then we have t raised to minus 2. Then we have a square, a raised to minus 2. This is the dimension of inductance. ml square t raised to minus 2 a raised to minus 2. Last we have capacitance. Capacitance C is equal to Q divided by V. The Q is the charge and V is the voltage. And we know that Q charge is equal to current into time. And voltage is power divided by current. Therefore, we will get I square T divided by power. This is just we do to derive the dimensions easily, just as a trick, or you can use it as a shortcut. Therefore, the dimensions of capacitance is equal to I square into, that is the dimension of current, into dimension of time divided by dimension of power. And again we can write that power as the dimension of energy divided by time, and here energy divided by time, and time t goes into the numerator and it becomes t square. And we have I is a square, and we have time, we have t square itself, and for energy the denominator we have m l square t raised to minus 2. Then we can bring it upwards, and the dimensions of capacitance becomes m raised to minus 1 l raised to minus 2. Then we have t raised to 4, and finally we have a square. So this is the dimension of capacitance, that is m raised to minus 1, l raised to minus 2, t raised to 4, and a square. So thus we can write the dimensions of this voltage, resistance, inductance, and capacitance. Take it down. I think you have understood how to find the dimensions of capacitance, inductance, voltage, and resistance. So let's do this question. Question 7 is, which of the following will have the dimensions of time? Where L is inductance, C is capacitance, R is resistance. So pause the video and try to do it by yourself. After that, I will help you. Have you got the answer? Which method you tried? Did you substituted the dimensions for inductance, then for capacitance? Have you checked like that? So let's try to do it. We know that the inductance L, we can write it as in terms of energy and current the whole square. Also capacitance, we can write it as charge by voltage. And again we have, so therefore LC is equal to E by I square into, and Q, we have Q here, the charge is equal to current into time, it is I into time again here, and voltage is power divided by current. Okay, therefore we will be cancelling I, this I square, this I and this I get cancelled, and then we have energy and time, then we have power again here, and we again know that this power is energy divided by time. Therefore energy into time divided by power is again energy by time. That gives energy into T square divided by energy. E and E get cancelled, and therefore the dimension of LC is equal to the dimension of T square. So dimension of LC is equal to the dimension of T square. So have you understood this? The dimension of LC is equal to the dimension of T square. So take it down. So the dimension of LC is T square. So this is not the answer because we need the dimension of time. Now let us check R by L. So we have resistance R is equal to power divided by current square, and energy inductance L is equal to energy divided by I square. Therefore R by L becomes R by L is equal to P by I square into the reciprocal of this, that is I square by E. I square by E. So therefore this I square and I square get cancelled, and we will get power divided by energy. And what is power? Power is again energy divided by time. Therefore energy divided by time into energy. Power is energy divided by time into energy. Therefore this energy and energy cancels, and we will get 1 by T as the answer. But we need not 1 by T, we will need the dimension of time. So this will not be the answer. But we have L by R here. So this will be the answer. So let's check this. Del by R is equal to what we will get? L is E by I square into resistance is I square by power. I square cancels, and this energy divided by power is again energy divided by time. For E and E cancels, we will get time. So option C is the answer. Question number 8. If C and R denote the capacitance and resistance, then the dimensional formula of CR is, we have to find out the dimensional formula of CR. We know that capacitance C is equal to charge by voltage, and charge is equal to current into time divided by voltage, and voltage is power divided by time. Therefore we have I square T divided by P. This is capacitance. And resistance R is equal to P divided by I square. Therefore C into R is equal to this I square T divided by P into P divided by I square. This P and I square cancels, and we have dimension of CR is equal to the dimension of time. Therefore the option is option number 1, that is A. So please take it down. I hope you all like the video. I think you have understood all the problems that we did today. So do more problems and practice well. Please do like, share and subscribe to my channel. Share it with your friends so that they may also find it beneficial. So see you in next video with more beautiful problems and more beautiful concepts. So thank you. God bless you all.